Hi, I'm Andrea and welcome to Productive C#. In this video, I want to talk about the ThreadPool class in .NET. Here I have a console application and I'm doing a loop that executes 10 times a portion of code. This portion of code is basically printing to the console an operation started, simulate a long-running operation like waiting for 100 milliseconds, and then print that the operation is completed. If you run this code, you can see that obviously all the operations run synchronously, one after the other, and the entire process takes 10 seconds, because each operation takes about 1 second. So now I want to show you how you can use the ThreadPool class that has been introduced since .NET 1.1 to run this operation asynchronously and in parallel. So it's fairly easy to use. You do ThreadPool dot QUserWorkItem. This is the method that pretty much you're going to use when you work with the thread pools. It takes a wait callback. This is a delegate that accepts a state as an object, and it's return void, so it doesn't return anything. So let me say I want to use a number as the state. That will be basically the I, and then I can put the logic here. So let me move these 3 lines here inside this code here, and the second parameter is actually the state I'm going to pass to this delegate, and I'm using I, that is the variable of the loop. Of course, now I'm not able to use I here. I need to use n, so that I'm going to use the state passed to the operation. So this is actually how you use QUserWorkItem. So what's the difference now is that these 3 lines here will execute in a different thread. The number of threads that the thread pool uses is beyond your control. You have a bit of a flexibility in terms of how the maximum number of threads that the thread pool can use and the minimum number of threads, but it's usually good practice not to change that and let .NET Framework to manage the threads under the covers. So what happens is that the framework creates a set of threads and then schedule the work on those threads. And the interesting thing is that the underlying threads don't die when the operation finishes, but they will be reused. This is a way to improve performance. If you use the thread class directly to create your own threads, all the threads will always die when the operation ends. And threads is something that takes some resources, some system resources, and it's not all the time very efficient to spin up threads manually using the thread class. So the thread pool has been introduced so that you can let the .NET Framework to optimize the thread generation for you. And the thread will die when there is not enough demand of work items. So let's run this code and let's have a look at what actually happened. If I run this code, as you can imagine, all the operation runs partially kind of in parallel. So that's also what you see in the console, is that the operations are mixed and matched, right? You have start and end and completed operation mixed. But what you probably notice that it takes significantly less time to actually finish because the operation use the number of cores available in a machine to do the work. Okay. Let's see what else there is to know about ThreadPool. So one important thing to know is that the threads that the ThreadPool creates are always background threads. What this means is that if the program reach the end, all the background threads will be killed. So let's say, for example, I remove this console read key here at the end. So if I run this program now, the main basically immediately create all this asynchronous operation, but then immediately ends, and this operation never runs, and so basically nothing is printed to the console because there's no chance for this operation to actually run. Let's say I had a bit of a thread asleep here. Let's say I'm going to wait for 1 second and see what happens. If I run this, you will be able to see that at some point when the program finishes, after 1 second, all the operation aborted. Okay, so that's very important to know. While if you use the thread class directly, you have the ability to choose if you want to create a foreground thread or a background thread. A foreground thread is a thread that basically If the program ends, the program basically wait until all the foreground threads are completed before actually ending, while background threads are always terminated if the program ends. So that's something to keep in mind. ThreadPools is used when you want to deal with the background threads. There are some limitations, of course, on using ThreadPools. They don't provide a easy way to cancel them. You can't control the priority of the operation you want to run. You can't actually join and wait when the operation complete. And there is no way to know if actually the operation completed, and no way to get a result back. As you can see, the delegate that you pass to the QUserWorkItem method doesn't provide any value. The ThreadPool is a kind of old school way of handling threads. Nowadays, .NET provides the task parallel library. Basically is an abstraction on top of threads that allows you to do asynchronous operation, and is always, most of the time, always better to use the task parallel library directly. Under the covers, the task parallel library default scheduler use a ThreadPool, but there are better mechanisms, to deal with asynchronous operation in .NET these days. But the ThreadPool is still a requirement for passing the Microsoft C# Specialist certification, so it's something you need to be aware of. Thank you very much for watching.